Alright, on your graph, you have to have labels and a title. You have to have a scale, and to get the scale, count the number of lines, take the number of lines divided into the largest. Got it backwards. The largest number on that axis. That would be like the X or Y divided by the number of lines. Alright, so we're going to do that, and then we're going to, and this is where y'all are confused, some of you. You're going to take and round up to, now I'm going to list all the general possibilities, and hopefully you'll see a pattern. The pattern is, maybe I need to round it up to 0.1, or I need to round it up to 1, or I need to round it up to 10, or I need to round it up to 100, or 1,000, depending on how big the number is. Now, that's the one of the series. The other is 0.2, 2, 20, 200, 2,000. Okay? It might be a smaller number. Or on one of your graphs, it was a 0.5, a 5, a 50, a 500, a 5,000. I call these multiples of 1, 2, and 5. What I'm doing is I'm multiplying 1, 2, and 5 by some power of 10. That's what I call a multiple. I can divide it by 10, divide it by 100, divide it by 1,000 to get a decimal, or I can multiply it times 10 and get 10, 100, 20, depending on how it's going to round up. So if my number is, when I divide, is 0.01, okay? 0.015. I want to keep this decimal place, but I can't say 0.1 is going to be my interval, my scale. I have to say 0.1 is rounded up. My scale will be 0.05. That's rounded up. Now, I know y'all don't know how to round. We're going to fight this for the first month of school, because y'all cannot round. I don't know where we went wrong in rounding. Y'all can't round. What? Because, oh, you're right. It could be 0.02. I'm thinking about y'all rounding instead of, so you're right. It should be a 2. Should be a 2. Okay? Best fit line. In general, you want as many data points above as below the line. Now, if I write it on the board, I'm not writing. Once you get your best fit line, choose a point on the line, not on the data table. Don't use data table at this point. I don't want to see any. I don't want, even if your data table dot is on the line, I want you to pick a different one. Okay? I do not want you to use a point that's on your data table. That's clear. Because I want you to learn that it has to be on the line, not from the data table. So choose a point on the line near the top and one near the bottom. Use the formula for slope. M equals y2 minus y1 over x2 minus x1. And we've gone over how to substitute in that. Make sure you use units from the labels. Okay? Use units from the label. Last part, the formula for a straight line. The formula for a straight line, you've learned this in algebra. Y equals mx plus b. The formula for every graph is different. The formula for every graph is different. So if your graph is diameter and circumference, then what is the label for y? What is the label for y? The y-axis. What is y? What does y mean in this formula? It is the circumference. Y means y-axis. So what is the label of the y-axis? Circumference. Equal. The m is the slope, and you figured out the slope, right? And it's 3 point something. Supposed to be. What is the x in this formula? Diameter. Plus, what is b? B is the y-intercept. What does that mean? Some math term, y-intercept. What does that mean? It's where the line crosses the y-axis. Where your line crosses the y-axis. In our graph, our line crossed the y-axis at 0. So plus b is 0, so we don't write it down. If it's 0, b is where that line crosses the y-axis. Sometimes you graph something and it looks like that. Well, it crossed the y-axis way up here, and that's an important point, that it didn't cross the y-axis at 0. Okay? But our graph, both of our graphs that you've done so far, cross the y-axis at 0. So if you know an abbreviation for circumference or an abbreviation for diameter, you do not have to write it out long like this. You can write it short. Does anybody know an abbreviation for circumference? What?
CIR.
What?
CIR.
That's just shorthand for it. I'm actually talking about a mathematical. C equals. Anybody know one for diameter? D. 3. D.
What are the numbers?
The numbers are what you figured out for the slope. I don't know what your slope is. Everybody's slope is different. So I'm not telling you the number to put in, other than it's going to be 3 point. It should be 3 point something. It should not be 5. All right, so that's the formula for this one. Now, the one that you're working on for tonight has got GLUG, or GU, is it GULG? And it's GL is the unit, and we have ZATs like that. So, I'm going to figure out the slope, M equals, and I'm going to figure out the slope. Then, up here, in this area, I want you to do the formula. So, on your graph of the circle graph, put your formula up here. Now, you notice that I always start with the formula, don't I? Then I plug in numbers. I expect you to do that too. If I model it this way, I expect you to model it this way on your paper. So I expect to see that formula written here where you figure slope. Okay, like that. And start down from there. Then up here in this area, let me erase this extra garbage I put on here. In this area, I expect you to put y equals mx plus b. Then I expect you to substitute in c equals my slope, 3 point something, and diameter. Now that's going to be your formula for that one.
B is where the line across the y-axis is zero.
It's 0 because we talked about why it's 0 yesterday and the day before. It's 0 because 0 diameter, that gives us a 0 circumference. This one is also 0. If you look at your line, it carries you back through 0. You can see that. So up here you would put y equals mx plus b. And then you substitute in what y is, and y in this case is about 12. GL per ZT. I have that over here on the regular board, written down how to do it. Okay? All right.